Hi, I'm Daisy Cagle, and I'm doing my video 2 on genetic mapping. I'm going to be using the German Wirehaired pointer for my examples. The 3 linked loci I picked, I don't know if they're truly linked. I just kind of picked them because they're visibly, you can tell what I'm talking about. So we have liver spots or no liver spots, fully wire-haired or partially wire-haired, and a face blaze or no face blaze. In this picture, this is my dog Vegas. You can see that she has a face blaze, a little white on her forehead. She doesn't have liver spots on her body, and she's only partially wire-haired because her body isn't fuzzy like her face is. So here's my genetic map for these 3 loci. And for an example genetic cross, you could see that using this map, if you did a double crossover event with the top and bottom being the parents, you would see that the progeny, do a little this number, and you can see that in that picture I drew. And your progeny would be L, little h, little b, or little l, big H, big B. And they're both heterozygous progeny. So for a heterozygous individual, which my dog Vegas is according to this made up map, that's another picture of her. You can see all the genotypes that are observed when crossing a heterozygous individual with a test cross homozygous recessive individual and all the observed traits. And then I calculated the probability of each genotype, and I also included the phenotype so you can easily tell what it looked like. And here are some examples of my calculations for a double crossover event. You would do 0.1963, which was the measurement of the first part, and 0.164, which is the measurement of the second part of coincidence, and that would give you 0.0162. But that's the probability for just a double crossover event. But to find a specific genotype, in this case, we're looking at little l, big H, big B, which would be no spots, full wire, and blaze, that top dog. You would multiply that number by a half and you get 0.0081. And for a single crossover event, you would do the first measurement, which is 0.1963 minus the probability of a double crossover event, 0.0162, and that would give you 0.0032. But once again, that's just the probability of a single crossover event. So you have to multiply that by half, and that'll give you the probability of a single genotype, in this case, big L, little h, big B, and that is 0.0016. And that would give you that bottom dog, liver spots, part wire with a forehead blaze. Here are my references. I got some of those pictures from the AKC website, and then some of them were my own dog, and then the rest of the material came from the PowerPoint slides. Thank you.